Hello everyone, welcome to Automation Community. In this section, we are going to see about logic gates in CX Programmer. Before entering into the topic, kindly like and subscribe our YouTube channel for more updates. So, logic gates programming in CX Programmer. So, let's see three logic gates in this section. One is AND, and another one is OR, and the next is NOT. So, let's see about AND gate. We all know about the truth table, right? So, this is the truth table of AND gate, and we are going to perform this logic in CX Programmer. So, here we are having two inputs and one output, correct? So, in CX Programmer, we have to use two inputs. Let's name that as in1 and in2 and output as out. So, only two inputs and one output, and for this we have to use this for condition. If both the inputs are off, output should be off. If any one input is on, still output have to be in off condition, like that. So both the inputs are on, then only output have to be in on condition. So we'll see how to do this in the CX Programmer. So let's see about OR also, OR truth table also. OR is like opposite to AND. If any one input is on, output will be on, correct? So NOT is having only one input, which means it's like a complement. 0 means 1, 1 means 0. That's it. So let's see AND gate in CX Programmer. So I'll create new project. So it's created. So as we have seen, we need two inputs, right? So I'm going to use normally open contact, and I'm naming this as in1. Sorry, this have to be addressed right. 0.00. Just click enter, and it is asking for the comment, and give this as in1. Click OK. And let's take one more input. So now we have to use one more input, no? That input where you are going to keep, whether in the same run or in the next run, and how you are going to connect these two inputs to perform the AND gate for that particular output. So think about the truth table now. If both the inputs are off, output have to be off. If both the inputs are on, output have to be on. Both the inputs must on. That means what? It should be in a series. See, you can confirm this statement with these two also. If any one is off, output have to be off. That means what? In the series, if any one input gone, you cannot get the output. So AND gate is nothing but a series of connecting two inputs to get the AND performance in output, right? So let's see that. So I'm going to put the second input in series to perform the AND gate. I'm naming this as in2 and take a output, and I'm giving an address and naming that as out, right? Going to connect this rung with horizontal line, right? So just click on escape. Now both the inputs are connected in series with the output. So let's see how this is going to perform, whether we are going to get the result for AND gate or not. So I'm entering into the simulation mode. Right? Fine. So now the rail is active now. Now let's see the first condition, 0, 0, 0. So 0, I'm not turning on the input. And same, this also I'm not turning on. Output is also 0. So the first condition is true, right? I mean the first condition we have achieved it, right? 0, 0, 0. Let's take 0 as off condition and 1 is on condition. So both the inputs are off, output is off. What is the next one? 0, 1. So this, let it be, we are not going to disturb this first input. So let's turn on the second input. So second input is in on condition, but still output is off. So the second condition is also we have achieved. So 0, 1, 0. Correct? 0 means what? Off condition. So output is an off condition only, no? Yes. So what is our third condition? 1, 0. So first I'll turn off this. So what we have to turn on now? First input. Turn on. So now look at this. 1, 0, 0. So the third condition is also true. Correct, na? Third condition is what? 1, 0, 0. Correct. What is the last one? 1, 1, 1. Now I'm going to turn on both the inputs. Let's see whether output is in on or off condition. So I'm going to turn on this, which is making my output to on. Correct. So my output is on for 1, 1 condition. So this is nothing but a AND gate. So while you are going to get the result for AND gate, you have to perform all 4 logic in one concept. It's not that each condition is having each rung and each line. I mean, there cannot be the different logic for this. This is the only concept for AND gate. So you have to put both the inputs in series to get the result. Understood? So let's turn off both. I'm going to the programming mode. So AND is done. So AND gate we have done it. Correct? So let's go for the next gate, which is nothing but OR gate. So OR gate is what? Any one input is on means output can be on. If both are off, then only output have to be off. So let's see how to do that. So I'm going to use same input. Okay. Now the question is how I'm going to connect. Whether it is in a series or in some other way. So series I have already done. If I connect that in a series, it will become the AND gate. So what is OR? OR is like an option. This or this. Correct now? OR is like an option. This or this. So this or this means I can go for the parallel option. So what this parallel option will do? If any one input is on, output will be in on condition. So I'll give the same. Okay, I'm going to use a different output because already I have used 100.00 as one of the output. So I'll use 100.1 and name that as out 2, 1 because that is out, no? So now let's name this as out 1. Right? So I'm going to connect these two using the vertical line. Okay. So I'll do one thing. Just delete this. To get a parallel contact, make use of this one. Okay. There will be an option like putting single contact over here and we can connect using the vertical line. So now you can make use of this option, new contact OR. So if you click and keep it here, it will create a new contact. That's it. So immediately it will get connected. If you see, both are connected. Now you can put this here and you can connect as usual. Correct? So now it's done. So let's move on to the simulation mode. It is transferring and it is ready to use. Now OR gate is what? 0, 0, 0. The first condition is true. What is the next condition? 0, 1. So 0, 1. So what I'm going to do, I'm going to turn on this input. So I have used some different address. So no issues. This is not the same as IN2. So okay, let's do one thing. Let's go to our programming mode and change the address of this. I'm going to edit. So what I'm going to do, I'm giving 0.01. Right? So now this is the same address of this. Let's go to simulation mode. Now fine. 0, 0, 0. Now I'm going to do 0, 1. So this I'm not going to disturb, and I'm going to disturb this. On. So output is on. So this is our gate, right? You can see for the same 0 and 1 condition, this output is off. But our condition output is on. So let's turn off this and turn on the first one. 1, 0. So this is 1 and this is 0, but still output is in on condition only. Because 1, 0 is 1 in OR gate. Correct. What is the last one? 1, 1. So turn on this. Still this will be in on condition. So 1, 1, 1. So OR gate is done. Correct. So AND gate will also be having 1 for this condition. 1, 1. When both the inputs are on, output will be on. So that's it about AND and OR gate. And we have one more gate which is NOT. So NOT is having only input. If 0 means 1, 1 means 0. So how to perform this? Only one input. Let's take only one input, 0.00. Okay. So let's take one different output, 100.2. Okay, let's name this as out2. Okay. And connect. Right. Fine. So now what is our condition? 0 means 1. Correct. So let's move on to this. Now see, my output is 0. Sorry, my input is 0, but output is 0 only. But this is not my requirement, no. My requirement is what? 0 means output should be in on condition. So, but for normally open contact, I cannot get the condition. So what I have to do? I have to go to the programming mode and need to think about it. So normally open contact is not working for NOT gate. So what I can do? I can introduce this normally open contact. Instead of using, normally open contact, I can use NC. Normally closed contact. Give the same address. Just delete the normally open contact. Okay, fine. So now let's see, instead of normally open contact, I'm using normally closed contact. Let's go to the simulation mode. Right. We got a condition. You're not disturbed the switch. That means what? You have not forced the input, but still output is a non-condition. That is the working of normally closed contact. If you are not doing anything, I mean if you are not disturbing the input, output remains in a on condition. If you disturb, if you change the state of that input, output will be off. If you see, if I am forcing that to on, what is happening? Output is off. Correct? So this is NOT gate. So this is AND, this is OR, and this is NOT. So I hope you have understood the basic logic gate concept. I will meet you in the next session. Before that, like and subscribe our YouTube channel. Thank you.